friends, welcome you all in the video graph data structure. In our previous videos we have discussed regarding trees, we have discussed regarding types of data structures, and we have seen that data structures, they are classified into two major categories: primitive and non-primitive. In primitive data structures, we have seen that integer, float, character, these are the data structures which comes under the category of primitive data structure. And in non-primitive data structure, again we have discussed that these are classified into linear and non-linear data structures. In linear data structures, we are having arrays, stack, queue, linked list. Similarly, in non-linear data structures, we are having trees and graphs. We have seen that trees is a collection of nodes in which one node is designated as root and other nodes are classified into left and right childs. If there are no further nodes, that particular node it is called as child, and based on that particular things, trees are divided into binary tree, complete binary tree, binary search tree, red and black tree, and so on. In this way, now we are going to discuss regarding the graph data structure, because trees and graphs, these are very important concepts in designing operating systems, database management systems, and other applications such as computer networks and other networkings. So in this way, graph is also one type of important concepts in data structure. Now coming to the definition of graph data structure, a graph is a non-linear data structure consisting of nodes and edges. How to define a graph? A graph data structure is nothing but it is a non-linear data structure consisting of nodes and edges. The nodes are sometimes also referred as vertices, and edges are lines or arcs that connect two nodes in the graph. More formally, a graph can be defined as a graph consists of finite set of vertices and set of edges which connects pairs of nodes. So what is the definition of graph? A graph consists of finite sets of vertices or nodes and set of edges which connects a pair of nodes. So diagrammatically, this can be represented as, this is a graph. So these are different nodes, 1 2 3 0 1 2 3 4, these are nodes, and these nodes are connected, and this connection, this particular line, it is called as edge, and these nodes are also called as vertices, like 0 1 2 3 4, these are called as vertices, and the line connecting between these vertices, it is called as edges. So a graph consists of finite sets of vertices and set of edges which connect a pair of nodes. So this is a diagrammatical representation of graph. In the above graph, the set of vertices are 0 1 2 3 4 and set of edges are 0 1 1 2 2 3 3 4 3 4 0 4 1 4 and 1 3. These are set of edges: 0 1 1 2 2 3 3 4 0 4 1 4 1 3, 0 4, 1 4, this is 1 4 and 1 3. So these are set of edges and set of vertices are 0 1 2 3 4. Edges is nothing but they are connecting between the two vertices. Now vertex, each node of the graph is represented as vertex. So 0 is a vertex, 1 is a vertex, 2 is a vertex, 3 is a vertex, 4 is a vertex. Edge, each edge represents a part between the vertices or a line between the two vertices. So edge is nothing but it represents a path between the two vertices or a line between the two vertices. Like 0 4, this is the edge, 0 1, this is the edge, 1 4, it is the edge. So like this, these are edges. Graphs are used to solve many real life problems. Graphs are used to represent networks. The networks may include path in the city or telephone network or circuit network. Graphs are also used in social networks like LinkedIn, Facebook. For example, in Facebook, each person represented with a vertex or a node. Each node is structured and contains information like person ID, name, genders and local. So graphs are having many applications and they are used in computer networks, they are used in the analysis of algorithms, they are used in operating systems and so on. Now coming to the types of the graphs, so we can divide the graph into two major categories, directed and undirected, directed and undirected, and also third category is weighted graph. So undirected graph first we will discuss. Undirected graph is a graph in which all edges are bidirectional, that is the edges do not point in any specific direction. So what is undirected graph? Undirected graph is a graph in which all the edges are bidirectional, that is the edges do not point in any specific direction. Like 1 2, 2 1, 1 4, 4 1, 4 3, 3 4, 2 3 or 3 2. So like this there is no direction. So these are bidirectional edges. So there is no direction between the edges. So that particular graph it is called as undirected graph. An opposite of that is directed graph. A directed graph is a graph in which all the edges are unidirectional. The edges point in a single direction, like 1 2, 4 2, 3 1, 3 4 or 2 4. So this is a directed graph, means there is a direction between the edges. So that is called as directed graph. Now weighted graph. In a weighted graph, each edge is assigned a weight or a cost. For example, consider a graph of 4 nodes as shown in the below diagram. So this is a weighted graph. Each node is assigned some weight or certain value, that is called as weight. So for this 1 2 edge the value is assigned 1, that is called as weight 1. 2 3 the value is assigned 2. 1 4 that value is assigned 3. 4 3 the value is assigned 2. So in this way there is certain value assigned to the each node. That particular graph it is called as weighted graph. That assigned value may be a weight or cost. So like this there are certain weights are assigned to the edges of the nodes, edges of the graph. So that particular graph it is called as weighted graph. So in this way the graph data structure can be classified into directed, undirected and weighted graph. In our next videos we will discuss the remaining concepts of the graph. Thank you very much.